It was like, define some variables, check some inputs, need to protect X and Y for reasons. But like these are like 3 things now. That is a lot easier to hold in your head than the whole thing that was bigger than my slide, you know? So with this sort of summarization and putting like blocks or chunks together in one summary, that is easier to manage, right? So you could go on and look at more code, but that's not the point of this. The point is that we use our long-term memory to help us aggregate items to something more manageable in our short-term memory. So we had some R knowledge, and that allowed us to make some sense of the C code. So some knowledge transfers. Yeah, and we had some sensible names, some like code words that we associated with something, and it activated some long-term knowledge. That's how we made sense of this. That's how we like probably fared better on the C code than like the original pseudo R code, right? So now I've warmed you up, basically. And now we're gonna read a third part. And now we're gonna go a little bit. So this is a function that modifies the right-hand side of a formula for reasons. And the thing that you might want to spot in here when you're trying to read this is that we're defining a function called drop strata, and then we're going to call drop strata multiple times in this. AKA, we've built ourselves a recursive function. And if you're like, oh no, welcome to the club. So a little bonus tip when you try to read somebody else's code in a package, and there's no examples, it is an internal function, it's not being exported, there's not much to go on. Go open the tests, because if nothing else, you get some examples, and you get a little bit of a glimpse into what the person who wrote this cared about. So here, we get to see that that function should remove a strata term, like in a series of plus calls, and otherwise don't touch it. Let's see how that looks a bit more. So if you put something in that's vaguely like A plus strata X, you should just get A back. If you do A plus strata X plus B, you should get A plus B back. And if you do anything else, rather than a chain of pluses, it shouldn't touch it and just return what you put in, right? So that's a little piece of background knowledge to make it easier to read that thing. The other part that I'm gonna like present to you as a little aid is that those calls that we're working on, the thing underneath it is the abstract syntax tree. And you can think of the first node as the function call. And then sort of the leaves of it are the arguments. So if you have strata of X, strata is like the first node, and X is the argument to it. And those pluses, they're also function calls. They take 2 arguments. They don't come like function argument 1, argument 2, but rather argument 1, function, argument 2. But still, like the first node is the plus, and then it has 2 arguments, A and B in our case. So that function then tries to find structures like something plus strata in increasingly deeply nested trees, and tries to replace that with just the non-strata term, right? That's a lot. We're going to walk through an example, and we're not going to do the nested thing. But what that function basically does is sort of like walk that tree, walk down, dip down, apply itself to like the next branch down until it hits an end and it jumps back up. And this up and down is the thing that I find most confusing about it. So a way to not go completely crazy with this is to start with a simpler example. So we're just going to apply drop strata to A plus B, which means we should be walking through this thing and end up with A plus B at the end. And the other thing we're going to do is keep track of sort of how many levels down we are, right? So in here, first time we're dipping into drop strata, we're at level 0. And a plus b is indeed a call. It's even a plus call. So we're going to go in here, and we're going to call drop strata. So I'm going to make a note. Okay, we're on line 3, and now we're going to go in. And that means the thing sort of that we put in was expression, the second part, which was the A. That is not a plus call. It is not a call either. So we're down here, and then we're just going to return the expression. So we're going to leave the A untouched, and we're going to go back to line 3. So we're sort of like, we dip down to level -1, and now we're back at 0. And then we're moving on, and we're in line 4. And now we're doing the same thing for the third element of our expression, A plus B. That's B. So we would be like taking a note, getting ready to dip down. And we already figured out that if it's just a thing like A, whether it's A or B, it will leave it untouched and return it. So we're not going to go all the way down and stuff. I'm going to be like, you already know that this returns the B, and we're going to assign it to the right-hand side, so we can move on a little bit. Now we're checking whether the left-hand side is strata. It is not. The right-hand side is also not a call to strata. So what we're doing now is we're taking these two elements, and we're putting it back together in a plus call, and returning that. So that's when the function exits from level 0 and gives you A plus B. Okay, I get confused by recursive functions, at least to a certain degree. And sort of keeping track of where I am and where I'm going back to and how far deep I am helps me to make sense of this. And sort of this moment where you lose track of all the things you're trying to keep track of while you're thinking about where you are in the function, that is because sort of the place that does all the thinking, your working memory, is basically your short-term memory applied to a problem, which means it has the same capacity as the short-term. So only 2 to 6 items. So if you're standing somewhere trying to think about something and it's kind of like your brain's overflowing, that's pretty much what's happening. Yeah? So if you're reading code, be it other people's code, your code from yesterday or from 3 years ago, it might get a little challenging, and that is because of different ways that it's challenging, and that is for reasons. Basically, if you're not having enough information to make sense of what's going on, that's because your short-term memory has limited capacity. If you're lacking knowledge, that's not necessarily a capacity problem. That's activation. Like, you need to be able to retrieve that knowledge that you once read on Mastodon or somewhere else, a blog, a programming book, somebody else's code, all of this. And the third element of why it might be hard to read some code is just sort of the limit of processing power, because your working memory also has fairly limited capacity for this stuff. So yeah, I mean, that's how they work. You can't really change that, but you can help your brain out while you're reading and make that a little easier. One thing we did was to look for beacons, sort of like signposts about what is going on. This can be the names. Remember that first example was just nothing to hold on to in the C code. While we might not be C programmers, we sort of had some stuff that made us think of different concepts. It can be comments. And it can be something as simple as paragraphs. Stuff like lines of code that work on one thing are one paragraph, and then there's the next paragraph that does something else. Sort of this ordering already is an indication of what is happening and how you should be chunking and summarizing stuff. You might be just doing that in your head, you might be writing comments, and if something's really terrible and you need to understand it, you might go and rewrite the stuff. Refactoring is rewriting your code without changing its functionality, just so that you are easier to read it and understand it. Helping your long-term memory, well, having more knowledge means learning more. And there's a whole other talk to be given about how to do that in smart ways. But I just want to say, like, knowing more programming helps, but also knowing more about the domain that you're working with helps. Like, I would be utterly lost in the tidy models code, even if I was an incredibly programmer, if I had no clue about sort of stats models and machine learning. Knowing about what is supposed to happen helps you place things, understand things. And the last one, when you have this feeling of like brain overflow, go offload some information. You probably do this instinctively, but there's a good reason why you're doing it, and it is helpful. And you just like put it on paper or on your screen or like in informal notes or in documentation. Just offload some stuff. It's okay. It helps you. So those are the things that you can do to help yourself have it easier to read and understand code. And I'm going to segue into the second part, which is writing code. And I think a very crucial idea about writing code is that it's so that you can reread it. What is the kind of code you want to go back to and like reread and try to figure out what you meant or somebody else meant? And you know, like some people optimize it so it can be read ideally by machines for speed. There's good reasons to do that, but sort of the group that I work in leans a little bit differently, and we think that we humans are the real bottleneck in all of this. So we're optimizing for humans to be able to read the code. And I do like that idea because if it's easier to read, it's easier to understand. And the better you understand things, the fewer mistakes you make, and hopefully the better science you do with it. And I think that matters, especially in the context of R. So let's get to some practical things that you can do to write more readable code. And the first thing on the list are the names. Like I mentioned them before, and the reason they're so interesting is that good names help you activate knowledge from your long-term memory, right? That sort of like kickstarts your biggest helper. And an episode or example for this is Tidy Models Work. So we've been working at integrating survival analysis in Tidy Models, and we're sufficiently close that I'm daring to stand here and say coming soon for a suitable definition of coming soon. So parts of it is already out. Like we started working on the models in all of this framework, and you can go fit survival models in Tidy Models via Parsnip and an extension package called Censored. And one of the things we did for that was to give the predict methods a new type called survival, and that is the probability of survival at a certain time point. So here it is 2, that might be like 2 years down the line, because just predicting the probability of survival overall, that's pretty easy, right? It's gonna be 0 eventually. So we need some more interesting time points than that. And we called this argument time. And while I don't think that that was necessarily a bad name, it obviously landed up in this talk as an example. So what's the matter here? Roughly, there's a lot of time concepts flying around in survival analysis, right? So what time are we talking about here? For one, we have observed time. Then that's not the only component of like data for survival analysis. You have an event indicator that tells you whether there was an event happening or whether that observation was actually censored. So now you don't just have observed time, you have event time also and censoring time for the other ones. And 3 sounds kind of manageable, and we're like, okay, these are like so core. People are gonna be okay if we call this thing time when we sort of predict. might be here too, or maybe down there. And that was sort of like, we put some thought into this. We didn't just like willy-nilly call it time because we were too lazy. But that was when we did the models, and we sort of moved on and worked on the metrics to evaluate these predictive models and tidy models, and got to the part where we used that to do tuning and working on these metrics. There were a couple more time concepts coming in, and then it got really hard to be specific. And we started to referring to like this time as the evaluation time, to distinguish it from other times inside the calculations of the metrics. And I think it makes sense to call that the evaluation time, especially in the context of tidy models, which is for predictive modeling, and you're evaluating them based on performance. So we went and changed that. And the reason that we did all of this is that it wasn't a good name. It didn't like activate the right knowledge. And the tricky thing about names is they're not really like all that neutral. So like, not just like bad names don't just help you. They can actually hinder you if they make you think about the wrong thing. Then it gets really tricky. And time was not specific enough to immediately direct you to the wrong time concept, but it certainly like left you running a risk that you might misunderstand which of the many time things we were thinking about. So we went and changed things. And instead of time, we called that thing eval time for evaluation time. And we did that in June, and then we changed it in Yardstick, that's the package for the metrics, and then I had to go back and change it in Parsnip and Censored, which was like a little extra thing because we had already released that, and you don't want to just like swap out the name of an argument underneath your users, and you're like, what happened? So it's deprecated. We currently have 2, but the future will be better. So yes, we care about this. We did all of that because it's important, and sort of we figured out we sort of maybe made a mistake. And then while we were doing this in Tune, we had a closer look, and there's a bunch of helper functions that put things together, and inside these are more times. There was dot time, and I was like, isn't that eval time? I have to trace this through the whole thing. If it's eval time, I want it to be named eval time, because otherwise I'm spending energy on tracking this thing through 5 functions. Not good. So I was like, Max, can we change dot time to eval time? And he did. And then he also changed stats times in there too. So plentiful. Sorry for the roast, Max. And the whole episode sort of distilled for me that thinking about names or rethinking your names a separate step after you've written your stuff is well worth it. You're busy trying to get the code to work and do the right thing. You're not also having capacity in your working memory to think about good names. Do the one thing, then do the other thing. And sometimes that's at the end of like implementing one piece, and you're like, okay, I'm gonna go clean up those dot times and stat times and everything else. And sometimes it's further down the line after you've released some stuff, and you're like, probably should have named that differently. So names matter, and it's worth the effort just for the understanding and the clarity, both for your users and for you when you read that code. So much on names. The other thing I'm bringing to the table are a thing called code smells. And bad names are basically linguistic anti-patterns, things you don't want to do. And the code smells are structural anti-patterns, ways you lay out your code that doesn't quite work well for you. So the name originates in a book by Martin Fowler, Refactoring, Improving the Design of Existing Code. And the first time I heard about this is what I think of like an important introduction to this concept to the art community by Jenny Bryan, in her 2018 user keynote. It's called Code Smells and Feels. And I see it basically as the R edition of this. And she talked through several of them, and if you want to know more about them, I highly recommend that talk. There's a lot of them, and we're not gonna work through all of them. Well, we're gonna pick those two because we've encountered those already and have a little think about why that's an anti-pattern that you don't want to do. So if you have a long method or slightly more R language, a long function, that's hard to chunk. You have to do the work of chunking in order to be able to hold it all in your head to know what the function is doing, right? And if you have a long parameter list or a long list of arguments to your function, the longer it is, the higher is the risk that you overload your short-term memory with this, right? And the other one I want to pull out of that list is duplicated code. What that is I think pretty straightforward from the name. It's not quite like inappropriate intimacy. So duplicated code. This is a slightly stylized version of code that used to be in Parsnet. And I'm going to give you a little bit of time for a round of spot the difference. Okay, so the facial expressions are really interesting to watch, I have to say. Yay for being able to see your audience. Okay, so the difference, there is one, is right in the first line. It is not in the functions. The functions do the same thing, but they get assigned to as predict methods for two different classes here. And that would be a lot easier to see if you didn't have that duplication and just one function, call it predict climnet, that does some stuff. It's hard enough to read as it is, but at least the fact that this is the same, that the predict method for the two classes do the same thing is certainly easier to spot this way, right? So that's an example where a duplicated code is making it hard for you. But what if the situation isn't this, but rather this? Subtle difference. We don't have to try to figure out what eval Alex does. I haven't to this day. It's on my to-do list for after this. So this may or may not do the same thing, right? Let's assume it does something useful. So these two functions do different things, probably slightly different things, but different things. And you are running the risk of thinking that they do the same, right? So if we're looking at the code smell of duplicated code through a cognitive lens, then it looks more like this. With the exact copy, that's a lost opportunity of chunking things together that belong together. And if you have similar or even very similar code, that is the potential to chunk things the wrong way, put wrong things together in your head that are actually not the same. So you could think of duplicated code as chunking gone wrong. And that's all fine and dandy, me telling you what not to do. That's only half the coin, right? So what should you be doing instead? If there are anti-patterns, please let there be patterns. Yes. They're just called design patterns in this case. And I think of them as reusable solutions to common problems. So let's pick one of these code smells again, the one with the many arguments, and revisit that. So this is sort of the boiled down structure where you have a function, it has some arguments, and then it has a whole bunch of options. And sometimes you are in that situation. Like with tidy models, we're in that situation with a function called tuneGrid, which lets you do model tuning via a grid search. And we have options like a verbose argument that determines how chatty that function is while it's searching, whether or not you want to save predictions, or whether you want to extract anything from the models you fit along the way. There's options for parallel processing, and they matter. You don't want to just not put them to the user, right? Somebody might need them. But also, maybe not everybody needs them all of the time, and they're making this list here, this argument list, rather long. So a solution to this is to offload that a little bit. So the original function has like the main arguments, in our case here, x and y, and then it has an options argument. And the default for that is what a different function returns, myFunOps. And the job of this function is mainly just to take all these arguments, put them in a list, and then inside of myFun, you pick apart that list however you need it. But that means that sort of the signature of the function, the arguments to myFun, are pretty limited. That's just like x and y and the options. And if you need it, you have access to it. If you don't, it's not filling up your brain with like 4 options or more. And we do that in tidy models for tuneGrid with a ops function that's called control grid, because we're sort of thinking of them as control arguments. And then if you're eagle-eyed, you will also spot control base for sort of iterative tunings, and control parsnip. So the same pattern is reused multiple times. That makes it easier. When you're writing code, you're running into the same problem, and you're just like, oh, I know a way to deal with this. And it also makes it easier when you read it. You're like, oh, I know what's going on. So yes, here the pattern or the principle is to reduce argument clutter with options. And the bigger picture is that design patterns can help you lower the cognitive load. That's sort of the amount of stuff your working memory has to deal with, right? And they do that partly because they're patterns, and you're like, learn it once, apply it many times, learn it once, see it many times, recognize it, and then hopefully you pick a pattern that has even a little bit more, like sort of this decluttering of the argument list via a control argument. And if you like that sort of thing and want to know more, I'm going to point you to something that is work in progress, so not done, but at design.tidyverse.org is like a collection of these patterns. They mostly focus on the API, but there's some others as well. And it's a online book or like a collection that's going to be worked into a book. That's what Hadley's working on. If you like him to email you while he works on this, you can get on his Substack, or you just look whenever you have time and interest. But that's a place to learn some more about design patterns. And I'm going to bring you to another part about writing code that I do care about, which are tests. Because if you can't make changes because you're afraid of breaking something, Karavu is here to tell you it's already broken. So this was a lovely quote from her keynote a month earlier at PositConf. And case in point, that Glimnet parsnip code that you saw a stylized, sanitized version of, there was more of it. And I don't think any of us on the team were particularly keen to touch that. But it was not impossible because we had a bunch of tests. And the tests give you the freedom to refactor because they will let you know when you break something important. So you're not doing it accidentally and don't even know about it. So tests are great, but they're not quite like regular code because tests are a diagnostic tool. So make them obvious. If everything's fine and they're not breaking, they're just running and you never look at them and life is good, You look at tests when they fail, right? So write them for that moment when they fail. When they fail, you want them to be easy to read and easy to execute, so you can figure out what you need to solve, basically. So let's see when things fail. This is sort of a test stat output, and it kindly lets you know that my fun works is no longer true. And that's okay. I'm like, okay, my fun. And then you go look at what my fun works actually means, and you find out that it means at least 3 things. So it does like a setup, and then it has an expectation for it, and then it has a setup for a different thing, an expectation for that. And you're like, okay, so I only know at least one of them isn't working. And of course, you can go back and like peek at the line number, but wouldn't it be nice if it told you here what about my fun isn't working? You can get there by putting it into separate test stat expressions, right? So if it says that function can do thing 1 or thing 2 or thing 3, and if one of these breaks, it will tell you which thing. I find that rather nice. So again, specific names are really good. That's the thing that's shared with regular code. And now we're going to go see where things are a little different. So assume you have a test file like this. What if that second test breaks? You probably want to go in and do some interactive debugging, right? So you want like to be able to run myfun2 on dat and dat2. But in order to be able to do that, you need to go reread and execute the right parts of the rest of the script. Which in this case, you need to do quite a few things of this. So we're going to move things around to make things more obvious. And the first thing we're going to do is gleefully do code duplication. We're going to move all of the things you need to make all of the setup, all of the dats that we're making, we're going to move those into the test stat call. And yes, we are duplicating. But we want that right in front of us, so if something breaks, we come and we see it. The other thing that I don't like is when there's like a library call up there. Usually you don't need the whole thing. If you just need like the deploy mutate down there, then prefix it. And then you don't have to go scroll back up to call the library. The other thing that's still floating around in this is those skip statements. And while I have some sympathy for like a skip statement at the very top, because sometimes it does make sense to skip all of the tests in a file in a certain situation, sprinkling these skip statements in between the test stat expressions, you're not doing yourselves any favors, because now a skip statement applies to all that comes after it. And especially if you had like a third test stat expression, you need to remember that skip on OS Windows between tests 1 and 2 also applies to test 3. So we are going to move those in here. And again, a little bit of duplication, but we're having different goals here. We want to be able to know that this is the test that fails, and we want to have everything that we need to run this and debug this right in front of us. AKA, we want things to be obvious. And I think that is because obvious translates really well into fits into your working memory. You don't want to have to look up 1,000 things or execute 1,000 things before you can get going. So make your tests obvious. And if you sort of implemented some of the other advice, in particular to chunk your code into smaller functions and then combine those to do interesting things, you have a double win. Like, it's easier to read and it's easier to test, because you can make precise unit tests for like that thing, and then the interaction of your many little things is a separate test, but you're just testing the interaction, not the things themselves. That's a different test, right? So in a way, in the tests, we get to strip away that complexity instead of trying to accommodate it as in regular code. And that's sort of like the other direction. And that's why different rules or advices apply. That's why code duplication isn't that much of a problem. You want stuff to be obvious. So I want to leave you with two things in all of this. For one, I think having a mental model of how your brain works helps you to work with it rather than against it. So knowing how those limits manifest and how to support yourself. Your mind can only hold so much at a time, but you can support it so that that capacity that you do have, you can focus that on what matters to you and not on like details that you could have avoided. And the other thing is that if you want your code to grow in complexity, your mind's capacity is not going to, like, short-term memory capacity or working memory capacity is not going to grow with it. So what you need to do is to keep chunking and rechunking. And that's why refactoring and like upkeep or maintenance also matters, because that's the stuff that enables you to grow further. And if you're done with like programming and you want to get back to your science, yes. But if you want your understanding to grow, you also need to keep chunking that knowledge. So happy coding, happy sciencing, and thank you for your attention. It always takes a village. This one was mine. Thank you.
Okay, time for question. Tiempo para preguntas. No en portugués, por favor, porque no puedo traducir, pero en español y en inglés se acepta.
Hi. Yeah. You were talking about the abstraction of some functions, like when you hide some code in another function and you pass it to another function. But I want to ask you, what is your strategy to abstract or do not abstract? But because maybe sometimes you abstract so much and you like separate one thing into different functions that you add some complexity to your code for the readable part and for the performance part. What is your strategy to choose to abstract or to not abstract?
The hard questions to start with. I don't have like a fully formed strategy for like finding that balance. I think I'm okay with the uncertainty of that you don't quite know it, and you do want to like maybe think ahead a little bit, but you don't want to like try to think of everything on the first go. So I'm okay with things happening, like we released something, we learned something better, and then we're changing it. So like the flexibility to go and learn from your mistakes, I think is a good guidance to be okay with that uncertainty that there isn't a perfect answer, and it depends on like where you went with your understanding, where your audience in some sense is at, what is obvious or what is like good chunking depends on what your like knowledge already is. So I think that shifts over time, and abstract as much as you need to, and then when you're finding the limits of that, then go further. It's maybe a good approach.
Hi, Mauro here. Thank you very much for your talk and for coming. I would like to take the chance to ask you a question about not focusing on just one package, but you work in a collection of packages. So I wonder if you have any advice or book or recommendation to learn more about, okay, when you're working with a system of packages, how do you manage the architecture of the whole system? What good place to learn more about that?
One thing is like having a boss who designed that thing. No, it's like tips for like finding out where that balance is. I think an important part is also thinking about where in its sort of life cycle it is and like how complex it already is, because there's different aspects to like what is easy and what matters at different points in time. Like Tidy Mons, when it was smaller, it was more important to be able to like add more things easily. And if you have like a colossal test suite and like extremely patterned stuff, you have to like keep track of that before you add like a little bit of thing. So that's not what you want in like an earlier stage. But as you grow and there's more stuff to keep track of and more interactions, you're gonna grow like sort of the guardrails that you put in for yourself with like a more rigid structure and more tests. And it like what is important shifts. And if you find yourself getting hurt by your stuff regularly, I think that's a good indication that maybe you have to like go change some things. But if everything's working for you and you're not feeling the pain daily, then maybe you are in the right spot on sort of that continuum. So yeah. Don't plan way ahead, I think is the same answer to both of these. No, I have to flip the switch first. See, I'm not the only one with technical difficulties today. How reassuring. I don't think that that's region specific.
Hola, está funcionando en este momento. Voy a cantar.
Yes, hello. My question is, many programmers are now using artificial intelligence to help themselves code, but others believe it's a waste of time because you spend more time correcting what the AI does. What is your opinion? Have you used artificial intelligence to code, or what do you think about the topic?
I have not really used it, so my impression. Only one person talks. Okay, I'm back. My impression was that it's sort of like good enough to seem convincing in a lot of things, and then bites you with like something subtle. So I think the advice of using it for stuff that you can easily verify is a useful approach to it. And then, yeah, I mean, my younger brother was like, it's a text prediction thing. I'm like, yeah, okay. I can let my computer science brother tell me that. I'm like, sure, that seems like a good summary. Yeah, so I think some caution is warranted. The most use I've seen anyone get out of these tools is probably Hadley changing the style of whatever he has to say. So apparently he can rhyme now.
Hi, it's about documentation. What are your strategies about avoiding getting bugs in documentation? Because as your function maybe changes parameters or something changes, documentation can get buggy, and that's especially annoying for users, right? So are there any strategies that you use or your team uses to avoid that?
mean, an probably rather obvious answer is to keep the documentation close to the code. And like, I think a big help in that regard is something like Cognition 2, where you can write the documentation right on top of it, and not like edit the help files manually, because then it's further distance and higher risk of you forgetting something. I mean, R has some checks to like make sure you document all of the arguments and these kind of things. So whatever you can automate there is a helpful thing. And yeah, we do try to like have a mental checklist of when we're working with staff to check that also the documentation is okay. Sort of like, if you change something, does it have a test? Is the documentation okay? Does it have a news entry? So you can keep track of things.
Okay, we approach the time. Yeah.
One last. Is that good? I want to ask about the interplay of really fast code and easy to read code. So particularly my experience with C is that we could write very easy to read code, but to make stuff run really fast had to have very ugly, difficult to read code.
Yeah, I think that sort of like goes back to the crux of like who you're optimizing for. And we tend to start sort of with writing for humans, and then assess like if there's any really slow performance that we cannot tolerate, and then put in like write C code specifically for those parts if you need to. But that's not where we start. We do it if it's really beneficial, but yeah, no premature optimization.
Anyone else that I don't see? ¿Alguien más que no vi? Bueno, estamos en tiempo. We are on time. So please, one round of applause to Hannah.
Nos vemos. Hablo. Mañana nos vemos, los esperemos acá tempranito que vamos a dar más pegotines. Mañana está el sorteo del libro, que hay que estar acá, sacarse muchas fotos con el cartel para tener doble chance de ganar. ¿Qué más? Hashtag Latinar 2023, tienen que poner así nosotros podemos chequear todas esas fotos hermosas que tienen que estar acá tirados, saltando, haciendo cosas y diciendo gracias R Consorcio, te amamos y todas esas cosas, ¿está? O sea, varios, ¿está? Nos vemos mañana temprano. Y los que tienen beca van a recibir un correo pronto, así mañana temprano pasan por mi oficina. Pasan por mi oficina.